Welcome to States of Matter, Take 2. Okay, for our second state of matter that we are going to discuss, it is liquids. So here on this page we have some examples of liquids, and we're going to discuss the question, what is a liquid? So the first thing I'd like you to do is to point to the word liquid. You could just point to it on your screen, kind of like this, if you use your finger like mine. There we go. Okay, point to the word liquid. All right. And then I want you to look and find all the different times that liquid is used on the page. Don't forget this small one over here. Here. Okay. So first thing I'd like you to do is I'd like you to try to read this section all on your own. So you should pause me now so that you could try to read that. Okay. So now as I read it to you, I'm not going to say the word liquid. I want you to say the word liquid out loud when I get to that part in the reading. What is a... Some things are a... takes the shape of its container. A... has its own amount or size. You can pour a... Water is a... What are some other... Okay, so here are the things I want to really focus on. A takes the shape of its container. That means that it has no shape of its own unless it's inside of a container. So right now, these are in the shape of a cylinder. This one is in the shape of a rectangular prism, and this one is in the shape of this fish tank. I'm not sure what true shape that is. It could be a sphere. Okay. So each of these, if you took the water out of those different containers, it would have no shape. It would be flat. It's similar to this. If you look at my jug, the water in there is in this cylinder-shaped part of my jug. But if I take the water out, just like you saw me do, the water has no shape on its own. So it needs the container in order to have a shape. However, water does have its own amount or size. So the amount of water is usually measured in words, things like gallons, cups, pints. And how do we measure those? Let's look on the next page and look at that now. Look at these cups. Each cup has a different shape. Each cup holds the same amount of... Measuring cups show the amount or size of... So here's something interesting. This and this are holding the same amount of liquid, even though they're in a different shape, and it looks to me, I hope you agree, that the blue is holding more. However, they are holding the same amount. So, liquids, here are some facts that we need to know about liquids. Liquids take the shape of its container, so without a container, there is no shape. Liquids do have their own size or amount. And then how do we move liquids? We pour them. So whether we're pouring them out like I did all over myself or we're pouring them into a container, that's how they move. All right. A liquid is different than a solid. Let's look at some of these solids. Solids have their own shape. So you can see, look at all of these shapes. If I take this block and, well, actually, let me use another solid here. Here we go. If I take this crayon box and I put this crayon box on my hand, it's still a rectangular prism. If I take this crayon box and I would put it inside my water jug, it's still a rectangular prism. If I were to take this crayon box and put it outside on the deck, it's still a rectangular prism. It maintains this shape no matter where I put it. That is different from a liquid, because a liquid can change, it will change its shape if it does not have a container. So right now the liquid is in the shape of the rectangular prism, but if I take it out of that fish tank, it will not have that shape anymore. In fact, it will have no shape. So if we look at each of these solids in the picture, these will maintain their shapes no matter what. Now, shapes and solids have their own size as well. So liquids have their own size, and they're measured in words like gallons and cups and pints and quarts that we spoke about. Now, a solid is not measured in gallons and quarts and pints and things like that. A solid like these are usually measured in weight. So if we look at this, we can see here that we have our balance. This is called a balance. And this is measuring the property of weight, or how heavy these items are. Can you tell which item is heavier, the ball or the bear? The ball is heavier because the weight is down. This reminds you of a playground piece of equipment that you've been on. If you said a seesaw, you are correct. So on a seesaw, if you had me on one end and a first grader on the other, it would look like this because Mrs. Smith is a lot heavier. So we can measure solids using a balance like this. We measure liquids by the amount of liquid inside its container. We cannot measure a liquid if we take it out of its container. It just becomes a wide open flow. We need to have something, a container, to hold that liquid. Okay, so we will do some more study on liquids. I'd like you to take out this book now, and I'm going to tell you what page to open to in just a moment. Okay, please take out that science study notebook, that green one, and please open to page 10. So you should pause me now so that you can do that. Okay, so here we have a T-chart. You can tell it's a T-chart because it looks like a T. Okay. So what we're going to do is we're going to look at these three sentences. 1, 2, 3. If the sentence is true about liquids, we're going to put it here in yes. True. If the sentence is false about liquids, we're going to put it over here in no or false. Okay? True means yes, no, false means no. So what I'm going to do the first one with you, and then I want you to try to do the next two on your own, and then you'll check your answer with me. A liquid has its own shape. Does it have its own shape without a container? The answer is no. So you might want to draw yourself some lines to make it easier to write. It does not have its own shape. If you remember, how does it get its shape? By the container that it holds, okay? So now I want you to think about number 2 and number 3. I'm going to read them to you, and then I want you to think about them and put them where you think they belong. If you think it is false, it goes in this column. If you think it is true, it goes in this one. So number 2, I'm going to read it, then you're going to pause, and you're going to decide where it goes. Liquids have its own size. Do liquids have their own size? True or false? If you're stumped, go back in the video to where we read that in the book. Have its own size. True or false? You should have paused me. Okay. Number 3, it takes up space. Does liquid take up space in a container? True or false? Does it take up space? The answer's now. Okay, so it has its own size. That is correct. Liquids have their own size. Do you remember some of those size words? Quart, pint, gallon, cup. And number 3, does it take up space? The answer is yes. Liquids take up space. And what I'm